Hello! For those who don't know me, my name is Derek Bailey. I've been a wood turner now for over 40 years and taught for 8 of them. I don't know if you've noticed, if anybody's noticed, I've primarily aimed my videos at absolute beginners who have low on budget, don't want to be too ambitious, I just want to make tentative inroads into wood turning as a hobby, and using a small lathe, an Axminster, a small lathe, what they call a mini lathe. So there are certain restrictions to doing heavy bowl turning and this sort of thing, so I've aimed the majority of the work that I've done can be done on the small lathe, but I've not got round to actually showing people how to sharpen the tools, because if you haven't got sharp tools you can't wood turn. And I'm hoping that this video will give you a guide on what to look for in sharpening, what sort of profiles are needed on the tools, and how to maintain the tools when you've got them new, because after a few days they will stop cutting properly. So therefore this video may give you an idea on how to approach your first attempts at grinding your new chisels. Anyway, enough waffling, let's get on. Right, I want to illustrate the grinds of bowl gouges, and spindle gouges, and the difference between them, and why they're ground the way they are. It's all right saying they're ground, it's such a thing. If you may have heard of a 40-40 grind and what exactly that means. And it's quite difficult. When I was wood turning, I didn't bother too much as long as the thing cut, and I didn't do a lot of bowl turning. I did the occasional bowl turning, and I probably had one bowl gouge, and I didn't really take much notice. I just basically copied the grinding of the tool when I first bought it and kept sharpening it at the angle that I bought it. I didn't even consider altering the angles or applying a logic behind the angles and the grinding. So I think I'll have a look at the spindle gouge to start with. Now, if you notice, when they talk about a 40-40 ground, it's often referred to on the bowl gouge, but it also applies to the spindle gouges. The first angle is this, that's the actual angle there, is 40 degrees. And they have a second angle which on a bowl turning will be 40 degrees. Well, on this spindle gouge it's actually 45 degrees. So you could say it's a 40-45. And what it actually means, this top angle, they say 44, is actually termed the sweep. So it's swept back 45 degrees. And if you notice, if I go along the top and I get a ruler, get a ruler on that, you'll see that there's a slight curve, convex curve to it. That is the ideal profile for efficient turning. I don't know if you can see that there, it's just a slight rock on it. Now I have one which I ground myself. If you notice, the flute on this is shallower. This is a purchased one, and it's not 40 degrees, I think it's about 50 degrees, but it turns. I didn't really bother about it. And if you have a look on the top here, it's flat. So as long as it's flat, or ideally convex, you're okay. But if it starts to go convex, concave, then it's not going to cut very well. In fact, it's not going to leave a good finish if it cuts at all. So the problem is, how do we prevent that from happening? How do we prevent us getting a convex shape, sorry, concave, I keep getting them mixed up, a concave shape to the edge? How can we avoid that? And by using these samples, which I have, which you can buy, I put a link up on the screen. You can actually buy these. They're not actually used for cutting, they're just used as patterns for different grinds. And I'll go into the detail of the grinds and how they can be achieved on the various grinding jigs that are available on the market. I haven't got them all, but I've got a few. I've got the basic one, which is an adjustable rest. I have a Sorby one, which is an adjustable rest, but it also has a profile grinding attachment underneath, and this has been set up to use for grinding wheels. I have the Sorby Pro Edge here. I'll just do that down. I have the Sorby Pro Edge, which covers all the tools, whether it's from the spindle roughing gouge, the screw chisels, the parting tools, and it has a profile accessory. Profile accessory that goes in here. And then, if you're stuck for money and you don't want to lash out, these are quite expensive, like this profile one is more expensive than a lathe. This Sorby one, which is virtually a bench grinding version of this, is round about £100, something like this. The Sorby is round about £400. And then if you're stuck for money, like I said earlier, in one of my previous videos I've given plans for constructing an attachment to the Axminster lathe, which again was in previous videos. So I've taken the idea of the Sorby Pro Edge and set up my own system, something similar for holding the tools, which I'll come to later and I'll give a demonstration of it. So that's the cheapest method, and we've created a disc sanding attachment here which we can use to sharpen the tools. This is nowhere anywhere as near as good as the others, but this is if you want to just get started and you just want to keep on top of the edge. You don't want to reshape the tool, because you'll need a bench grinder and a very coarse belt on the Sorby Pro Edge to start reshaping the tools and altering the angles and the sweeps of the individual tools to suit your needs. Right, we go to the basic wood turning tool, which is our first grind at looking at of the turning tools, barring the screw chisels and the parting tools, etc. You see the bevel there, and round the top, it's square on the top, which is okay for turning spindles. In fact, there's a video I mentioned earlier that shows you can do quite a lot with this. If you grind it a certain way, you can do more than just taking square wood and making it a cylinder. You can actually do tapers with it, and you can do beads with it if you get a nice sharp corner and just relieve the corner, and that relieve the corner back there, grind that back so that we can get into doing beads. So as tools progressed, when I first bought my spindle gouge, it was like that. It was very similar to the spindle roughing gouge along the top, but as you can see, because it's a smaller diameter and it was ground at about 45 degrees. which again was okay for doing spindles. Certainly not inside or hollowing out, but it was certainly okay for doing spindles. So why did they introduce the sweep, which I mentioned earlier, or the secondary angle on the top? Why did they do that? So I'll get a small bowl here which will help you to show it. It's a bit dirty from previous because I haven't done a bowl. But if we go in like that, I don't know if you can see that, you might not be able to see that. The corners, or the wings as they like to say, were easily caught as the wood turned back. If I don't know if you can see it there. So these corners were caught on the inside of the bowl very easily. And so to do internal cutting like that, they made a sweep and got rid of those nasty corners. And it also helped for doing beads and etc. on spindles. So they introduced a sweep to it. Now this is what I first bought. This was the tool I used for spindle turning. I didn't do much bolt turning, and you don't do bolt turning with spindle tools anyway. But there are occasions where you can do what we call end grain bolt turning, which is actually hollowing out a spindle. And then they started to introduce that sweep back, as I mentioned earlier. Wherever I put them. Right. So if you have a look now at that, it's very similar, but now we've got a secondary angle along the top. And this is when it gets difficult, because when you first buy your tool and you haven't got the skills to grind it by hand, how do you get a consistent sweep and get it at the angle that you've been told is the best angle to get? So you get a jig, or you grind by hand. And I'll show you, I used to grind my tools by hand, and it was acquired skill over a few months. But you know, after practice you got a consistent edge to a certain degree. There were times when you couldn't get the flipping thing to cut because there was something you didn't quite get right, such as your muscle memory wasn't quite as accurate as it was the day before. So you spend your time grinding metal away, and this is why jigs came in, which saved a lot of trial and error, and repeatability was created. So you didn't grind a lot of the steel away. I mean, tools are very expensive, so all you really want to do is get the basic shape and just keep on top of the edge. So I'll show you how I used to hand grind. I can't do it now as well because I've got tremors, essential tremors, so I'm a bit tentative when it goes onto the grinding wheel. And you want a nice clean bevel if you can manage it, with very little facets. Now, as you can see, as I rotate that, the flatness of the wheel, and I simply rotate it like that, and that's how it came from the manufacturers. You didn't spend a lot of time in producing the sweep back or anything like that, because people have different likes and dislikes. So they had a standard grind, and that's what they did. Just produce one angle. Now, in order to produce a secondary angle, put a mark on there, whether it was 45, 50 or whatever you wanted, and that would be flat there. And then they'd set that at, say, 40 degrees or whatever, and they'd grind the two corners at the same time. You see the mark there? And then what we created was that horseshoe. By putting it on the grinder, obviously it's not designed for wood, but this is just a mock-up using a wood profile. And it created a horseshoe on there. So then, it was a matter of grinding that round so that that horseshoe thickness went to a cutting edge. So it created a guide for us, a contour for us to follow with the bevel. Instead of using the grinding wheel, which was only there to illustrate it, I'll show you on this of the rest, which I have done here. And then it was a simple matter of grinding this round until we could follow the contour of the flute and the angle and the shape of that which the angle makes with the flute when it's been ground back to that angle. So that is our sweep. So to make it cut, you simply use this as a guide. Now you can imagine how long this would take if it was steel. It's the reason I made this mock-up out of wood. Then you go up and you'd lift it off the rest like that. You can imagine how muscle memory would kick in at this stage. And that would be the cutting edge. And see how I followed the contour. See, I've got a few facets there, which isn't ideal. But you can see how that shape and profile came into being. And that's by using the hand, using your hand to grind the tool. And that's all I did. I didn't take it any further. And it did all I wanted to do. And again, I could do a little bit of bowl turning in an end grain bowl, actually where the grain is parallel to the lathe, and that's a normal turn in there along the top, and if you wanted to make an end grain bowl, you could then go inside. And because the wings were swept back now, you could go into the bowl there with a less chance of a catch or a digging. And because it was a short bevel, we could go right round into the corner and then across the bottom. And that's how the cutting edges and the bevels and the sweeps evolved. And after that, it was a matter of experimenting with different angles and different sweeps to achieve certain movements of the tool in the bowl. Right, now in our DIY grinding mechanism for the Axminster lathe, we're now going to grind according to the profile. the samples, the patterns. I've set this at an angle, the correct angle, so that it's touching that edge. I don't know if you can see it. It's exactly parallel with that edge. And then what we'd normally do, we'd get a Sharpie. I'll just get a Sharpie. And then I'd put it against there and just move the disc downwards like that, and put that paper there to show up to it to highlight it better. And you can see now that it's done the full length of that bevel. So now we're ready to set that in motion. I won't use this because I'll take away if I get it wrong, I'll alter the grind on that, and I don't want to do that because it's a pattern. So I'll go to this wood one. There, like so. Now if I was to grind that, I don't know if you can see it, but if I was to just grind that and just roll it, I'd get a cone. It'd cut, and in fact Robert Sorby shows you in one of their videos that you just rotate it round like that, but you get a cone. What I want is to get a sweep, so you won't. So without putting that there, I'd have to put my 40 degrees line there, and I'd have to start like that, and as I turned it I'd have to bring it round like that. I'll show you a different view. If I don't get in the way, you might be able to see it better. I put a line at about 40 degrees if I wanted, like so, and then I'd set that at angle like that. I don't know if you can see that. And as I turn it round, I want to be at the bottom of that flute, and then I want to be vertical. So you can imagine that's quite tricky to do. And then round the other side, so that I get equivalent of that angle there. And all that, so you have three movements. You have to press against the rotating disc slightly, twist and get it in perfect time, so that by the time you've got to the bottom of the flute you're vertical. Well, you can imagine that takes a lot of practice to get that right, and if you get it wrong you could get a catch. So the idea is that's why you lift it off the lathe, off the tool rest. So instead of having to do that, you can put it on the bevel there and then lift it up to make it that way, because if you were to just, you don't want a cone, you want the sweep back there. You want it swept back. That's, if you look at that, that's not a cone. It's that angle, it's kept the same all the way round. And in order to achieve that, you've either got to rotate it at the necessary angle like I showed, or lift it up, which I showed earlier, to maintain that bevel and use that bevel as a rest that you've made. And by feel, you can feel that you're still maintaining that bevel against the abrasive, which is quite difficult. So, in order to overcome that, they introduced a jig. I'll just take this off and come back to you. Right, this is where the jig came in. Now there's various jigs similar to this on the market. There's the Sorby, which I showed you, the grinding wheel Sorby. Now if we're going to use, what we'll get is a flat bevel on this. With the grinding wheels we get a concave bevel. There's not a lot of difference in performance.
If you get used to a concave bevel, i.e. you've ground your bevel on a grindstone, you get a concave bevel, you get used to that concave bevel, and if you're doing a lot of turning and then you transfer over to a flat bevel where the surface is flat, then you've just got to adjust mentally to it. But there's no great difference in performance between a flat bevel, so a concave bevel I should say. Right, so what was introduced was the to create that even grind all the way around the bevel. This was introduced by Sorby, by a few others. There is a one I'll put up on the screen. It's called a Wolverine, and that is a different kettle of fish. It's same principle. You have one of these to hold the tool in, but it's on an extended shaft here, and you have to bring it out, measure the distance between that, puts a Sharpie on to get the correct guideline, and then test it out to see if it removes the same amount for the depth of the bevel. So all you have to do with this is to get that projection the same from the distance from the edge of the holder to the cutting edge. So and then you set this at an angle and maintain that angle without adjustment. Once that's fixed, it's better to keep it fixed and not alter it. So I think it was about 2 inches if I remember rightly. I'll just set the gauge. just show you what I do. I have some markings here, some plastic stops here which I use to set the distance. Right, and then we put this in here, and that gives us our sweep back. I'll try and bring it closer. Set that on now. And by twisting it right round, we can create that sweep. So you've created that sweep back all in one operation. When I showed previously, I had to set the abrasive to the right angle, as I showed before, and then we'd to follow the contour of the horseshoe to get that correct. Well, this is all done in one. You don't have to mess around with it. And once you've set that angle and you've set the hole in here, which hole it is designated for this particular grind, and the angle, once you've achieved that angle, you don't alter that, you just move different holes to get different sweep backs. So obviously if I'm out here, I'll get a different sweep again. Now what you have to watch for, like I said earlier, is to watch for that edge not to be concave. It needs to be either flat or slightly convex. Now in order to achieve that, you concentrate more on the tip. So there I've got it flat, as you can see. I've got it flat. If I want to create a slightly convex profile on the cutting edge, we just dwell a little bit longer on the front of the tool. Right, as you can see now, because I've concentrated on that tip, I don't know if you can see it. Can you see how it's slightly convex? So all that is done in one movement, well, not one movement, but with one jig. You don't have to mess around with hand, and you can get consistency with this. So let's go to our pattern, the purchased samples that we can get. How are we going to use this to set up this jig? Well, we'll lock it in that position which I showed you earlier. And what we have to do now is put a Sharpie on here, on the front. Right. And because it's handmade and because it's a DIY setup, we've no idea what position we need or what angle we need to put it or what hole we need to use. So we use this as a guide to set our angles. So let's try this middle hole and we'll see if we can line up the bevel. Now it's quite high at the top, so if we go to the bottom one, the bottom hole, we don't have to go as high up there. So I've got it lined up with the bevel there. Can you see it? And I'll just waggle it from side to side now. I know which hole it is, which is that first hole. I've set the distance there. And now we're exactly hitting the full length of that sample bevel. So now we can put our tool in. We know the angle. We know which hole to put it in. So all we have to do now is to measure that distance from the end to the front of the clamp. So we put a stop on our desk, screw something down, so we screw something down here, and we know that that was the correct distance. So we get our tool, go to that distance we've set, go back to our that first hole, and then it's not set at the correct angle on this, but then we switch the machine on and then we grind according to what I showed you on the wooden samples. So that's how we'd use this jig and use the samples to set up the jig. We know that angle, we know which hole to put it in, and we know the length of the projection out of the clamp. So every time I want to grind that chisel now on the same bevel and the same sweep, then I know which setting to use. And that happens throughout and it's up to you to decide which bevels are convenient to you to use and which sweeps are convenient. And different sweeps and different angles, bevel angles, produce a different efficiency in cutting, and you can get, and it's amazing because of the length of the tool, that angle can be quite critical. And if you get the angle wrong, you could end up with the handle hitting the bed of the lathe as you're doing bolt turning. Because it's amazing how 1 degree on that angle, or 1 or 2 degrees, can affect the position of the handle at the lathe. So obviously that's why there's been a designated angles and sweeps, which I'll put up on the screen, and I'll try and indicate what those angles and sweeps are best used for. On the screen are the names of the elements making up the profiles used in spindle and bowl turning traditional tools. Here, profile A, which has a 35-degree sweep, is more suited to delicate spindle turning with small beads. Profile B is more suited to general spindle turning on the outside and end grain hollowing on the inside for end grain bowls. With the detailed spindle gouge, we're entering into the area of custom grinds, where highly specialised turning such as finials, etc., where extremely small beads are needed, then it's down to the wood turner to decide which angle he prefers. The bowl gouge needs to be stronger than the spindle gouge, and in that regard the flute has to be deeper and more closed at the top and less open than the spindle gouge we saw previously. Profile A has a 35-degree sweep and is used predominantly for general bowl turning work, both on the outside and inside of bowls. Profile B has a 50-degree sweep, thus creating a very small length bevel, which is ideally suited for turning at the bottom of the bowl, as the tool transfers from turning parallel to the bed of the lathe to turning at 90 degrees to the bed. As it traverses across the base of the bowl, the heel is less likely to bind with the wood as the chips are being removed. Profile A has a 35-degree sweep, which gives us a longer cutting edge. This is great for doing shear scraping, which is a common feature of bowl turning now with what they call the Ellsworth grind. I'll show you a diagram later on which shows you the full range of designated angles. I'm just referring to the purchased samples and templates. But the principle's the same. The longer the edge, the more you can shear scrape. Finally, we have Profile B, which is the 40-40 grind. This is the grind proposed by Stuart Batty on many of his videos, and it gives an excellent reason for the 40 grind and how, used properly, can produce turnings that don't tear the end grain. I suggest you watch that video. It's a highly interesting one and shows you advanced techniques. Over years of bowl turning, the traditional design has evolved into extended sweeps ranging from the fingernail through the Irish and Ellsworth grinds. Now many people experiment with the sweep and it's not set in stone anymore. These are just basic guides. It's left to the wood turner to experiment. I've shown you the profile grinding using a similar design to the Sorby Pro Edge. Now I've put the base back on, which can be used for normal sanding, for putting radius on things and that, but I've actually put a sub base on as well, because when you put the tool on here, you've got the ferrule which interferes with the angle. I want to be resting on there, not on the ferrule, so I've put a block of wood there that makes the ferrule, clears the ferrule from the actual sanding table. Now the beauty of this is you've got a variable speed grinding. So I usually go it on the downside. Upside you get a burr coming off. Downside, the burr, it takes a burr. Sometimes a burr is useful, but as you can see with normal abrasive, there we go, I've got a nice edge there, and that's keeping on top of the spindle roughing gouge. Next we have our parting tool. So I'll stop that. As long as you just keep it straight, see we're just about on the top there. Puts a decent edge on. Like I said before, this is only for maintaining the edge. If you want to reshape the tool, you're going to have to go to a normal bench grinder. Well, this is ideal for just keeping on top of the bevels that you bought from the manufacturer, and just keeping them sharp. Now we have the oval screw gouge. Now because it's an oval screw gouge, it has a curved surface, which when you put it on you've got to be careful you don't waggle it about a bit, so you're reliant on the bevel pressing on to the sander, to the disc sander. You can put a guide there, but the bevel's usually good enough as a guide. As I focused on the demonstration of the grinding attachment for the lathe, I didn't really focus on the angle there was grinding on this screw chisel, and I couldn't get the correct angle, the manufacturer's angle, due to the fact that the sanding table would not lower enough to reach the appropriate angle. That's a terrible grind, Derek. There's two facets there, and even the top grind was not evenly parallel with the cutting edge of the tool. Why I didn't emphasise that, I don't know, but that's a terrible grind, so please don't copy this. Use the angle that came with the manufacturer as a guide, rather than creating your own angle. And there we have it. So you can maintain the edges of your tool quite adequately on this setup, on this DIY setup. And then you just remove the sub base here. And then you can go back to normal sanding. A variable speed sander. Although the only downside is having to change. You see what's happening now, because I've used it on metal, it's made the sanding disc virtually unusable for wood now, because it's just burning the wood. So either you change it for a diamond disc, which you can get, they're not that expensive, you can get a diamond disc, or you can make a few of these discs, plywood discs, possibly even a bigger diameter, to reach so that you can make the tool go higher. Sometimes the angles, especially on using the grinding jig, the sorbet style jig, the tool can project higher than the disc, so you put a bigger disc on. And you could have a few of these discs with different abrasives on.